you very much. My name is Julija Anna Lisaja. I am a senior Java full-stack developer at Accenture with over 5 years of experience. And today I will share with you the story of my project and how it has used GitHub Copilot. And by the end of this demo, you will find out how you can implement this AI tool into your project and efficiently use it within both legacy and modern environments. So, first of all, let me tell you a bit about the project on behalf of which I am currently presenting. This is a subscription-based multimedia product distribution system that is operating within a dedicated European country. And when I first onboarded to a project, I was very happy to find out that it uses the technology stacks that I am familiar with. So it was written on Java and actually was used like the most recent version of Java at the time, Java 21. It also utilized Spring Boot, a very famous open source Java-based framework for web applications, and it was also cloud-based, which basically means that I can successfully utilize cloud certifications that I have acquired recently. So yeah. And when I then was introduced to the APIs for the project, I was again happy to find a very expected calls. We had a product calls, emails, users, payment and addresses, and all of these API definition plus technology stack plus the most recent versions of Java used paint me a picture of a fine-tuned and managed microservice system. However, only a bit later I started to notice that word microservice have actually never spoke during my onboarding, nor ever mentioned anywhere in the wiki. This is because all the system within which was my area of responsibilities in this project was a one big monolith with a lot of legacy code and technical debt. So let me first erase some possible confusion. When I'm mentioning legacy code, I'm not mentioning only code that was written like a very, very long time ago or was written on some legacy languages like COBOL and Fortran. I mean some usual problems that some project is currently, especially long-lasting project, facing. So here I have collected actually a couple of issues that our code base had at this time. So first of all, the architecture overall was monolithic, heavy coupled, and it was very hard to manage. The coding standards were very inconsistent. Basically, one developer goes to the project, reads something they want completely from head, then other developer comes to the project, reads something completely different. No consistency whatsoever. Test coverage. I would say that majority of the flow wasn't tested anyhow. No unit tests were presented for a lot of functionality, which basically means that every time when I need to touch something, to implement or improve, I need to waste like 90% of my development time to create tests completely from the scratch. For the implementation, I'm not even familiar with. Documentation. Well, I would say it was very unenthusiastic. It was presented, which is already a big advantage, but it was very, 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 very high level, and it did not cover like any major use cases, and also didn't provide any testing examples or any examples of, for example, errors or possible unsuccessful issues or all possibilities for successful issue, etc., etc. So all of this collected like in one piece makes the integration of any new functionality very hard and challenging. So have you actually familiar with any of these issues in your own code base? So have you ever had issue with documentation or test? Anyone? Maybe you can raise your hand so I can, yeah, definitely. So let me actually do the demo snap and reveal how this monolith actually looks like. So first of all, we have a single data source for all entities. User, address, products, everyone is retrieved from a single database, except emails. For some reason, we have like 4 management email systems. Till this day, I do not know the reasoning behind this solution, nor I understand the logic according to which any of these ML services are selected for particular events. Next, you might notice that some components are duplicated, so we have multiple addresses and multiple products. This is because there was many attempts to refactor these monoliths before me. All of them basically finished half-baked, they never was completed, and we ended up using all of these different versions of the API, which mean that we also cannot just remove them. Even though we have a duplicated address component, for example, we cannot remove it because it is used by one of our front-end application or any dependent service. So yeah, it also drastically decreased any readability of our APIs. Next, we have two APIs for effectively managing one entity, user entity. We have a user API and subscriber API. Both of these API doing completely the same thing. There was an idea, a big idea behind it, which I will explain you a bit later, but now please believe me that it was very inconvenient and confusing. Additionally, all of these APIs were interconnected in the more inconvenient and unexpected way possible, which making managing of all the system a very interesting experience, I would say. For now, I see that having legacy systems is not initially an issue in the project. It's actually a big luxury in software engineering when you are onboarded to the project which have completely no legacy code. If the project is long-lasting, it has some legacies, like the rule of the industry, unfortunately. And like, despite maybe being not really manageable, not really readable, legacy code still consists a lot of valuable business logic, which was at least time-tested. So we know initially, definitely, that it will work. It's not an issue until you need to make a big integration into your code. So it was decided to introduce new user API into these monoliths, which promises to, first of all, reduce all of this cognitive load of understanding the difference between user and subscriber. It promises also to clean up our database a bit, and it also promises to break all our existing flow in the process. So the implementation of this user API was considered like a very, very big, long-lasting epic, which had spanned like on hundreds of development tickets. And since we cannot get rid of this monolith, we do not have capacity to decouple it to the various like well-managed microservices. We decided to make an incremental refactoring of this legacy service in scope of each of these development tickets, reduce all deprecated flows, and basically fine-tuned all of our code base a bit. And this is when GitHub Copilot came to play. GitHub Copilot is a GenAI-powered code suggestion tool developed in collaboration with Microsoft and OpenAI and distributed through the GitHub platform. GitHub Copilot is available generally through multiple IDEs. It supports IDEs like Visual Studio Code, JetBrains IDEs, Vim's and NeoVims. Unfortunately, majority of the most recent and advanced functionality for GitHub Copilot is gatekept by Microsoft, so it is always available first in Visual Studio Code, but I still myself prefer to use it in IntelliJ IDEA, and I will also later explain why. Next, you can access GitHub Copilot through the GitHub portal itself. There it provides the functionality of GPT-like chat, which can use the knowledge base of the GitHub, like your repositories, your activities, and use it in the conversation, manage it, change it during this conversational like chatbot. It does also provide functionality to automatically review your pull requests, which is very convenient and widely used on our projects. And additionally, you can access GitHub Copilot through CLI. Basically, you can generate executable commands through textual requests. And you can also access GitHub Copilot through GitHub Mobile. There, only chat for you will be available. So now let me showcase you some real-life example about how I personally have utilized GitHub Copilot to modernize our legacy monolith. I already tell you that during the initial implementation of all changes, the only functionality that was available for us was the IDE one, so the chat and inline code suggestions. So I will mostly focus on this part of GitHub Copilot in this demo. New functionality in GitHub Copilot is actually introduced pretty often. And yeah, GitHub Copilot is pretty progressive on behalf of AI development. So it's also important to stay vigilant with all updates. So yeah, first, let's revision the first developer ticket that I have received in the project. So I will try to make this a bit bigger because I believe you will not be able to see it, and I really, really want you to see it. So let me actually read it out for you. Currently, address API is returning following response body. And we have a response body to JSON. I don't know if you see it, but basically this JSON contains multiple addresses. Delivery address, definitive address, interim address. Why do we need so many addresses in our user API? I don't know. Maybe it will be explained somewhere in the ticket later. This is not what we expected, as it do not fully correspond new address rules for name visibility. So we have rules regarding name visibility. Are these rules documented anywhere? Can I read them out? Well, a little spoiler, no. These rules were discussed only during Teams meetings, which I cannot attend because at this time I was not even a part of the project. So next, note that the response is from external API. In user API, address and points are used separately. So this JSON effectively is not even relevant for my task. Why is it here? Again, I have no idea. Also note that we need to make clear when endpoint is used either by user or a subscriber. So at this point you already know that we have like two entities to manage user, two functionalities to manage one user entity, sorry. And yeah, effectively, I do not know what this ticket wants from me. So what should be an end result? It is not documented. How I must like realize the functionality of separating user and subscriber? Should I create two separate endpoints? Should I add information into the response body? Why do you have so many addresses? What is the difference between definitive and delivery address? Where I can find the rules? What end result is expected from me? All of this, I don't know. This ticket is the only source of information for me for now. So this ticket is good from perspective of a developer who is already familiar with a project. It's the issue of presumable knowledge. I, as a new joiner, do not know anything about it. Well, I of course can ask the senior architect about details regarding this ticket, but I will not gonna do it. First of all, I am a senior myself, so different level of expertise is expected from me already, and second of all, the original creator of this ticket at the moment was on vacation, so I was not able to retrieve any additional information. So what am I doing? I don't know if with all of these changes I will be capable to go to another slide, but I will try. And yeah, now it should work. So, effectively, I am copying all the content from this ticket, and then I am opening the IntelliJ IDEA with GitHub Copilot installed. I can access GitHub Copilot chat directly through pushing this icon, and here in this chat window, I will ask GitHub Copilot to resolve all questions regarding this ticket. So let's see what it will be able to provide for me as a response. So first of all, it has defined the location of the class where I need to make change. Definitive address controller. This is already something. At least I can start doing something regarding my task. Additionally, it could define some components like user address service, subscriber address service. Again, at this point, I'm completely not familiar with the code base. Our code base spans like across hundreds and hundreds of files with a lot of repetitive and similar components. Now I can start actually doing my task. So let's go to definitive address controller and explore this old functionality. So first of all, I want you to witness this wonderful get mapping controller. So controller, this is how you implement, you create API with Spring Boot. First of all, this get mapping controller have like 3 path definitions. Why? This is the ancient artifact from previous legacy refactoring attempts. And all of these API are now used by some of the front-end service. The definition of these APIs is also inconsistent. There's some plain text, there is some that is appended through the constant. And what I want to actually focus you is to this wonderful path variable, UUID or subscriber ID. This is how the management on different user entity is realized in the project. So we have effectively 2 different parameters that are sent entirely coupled into this get method and to any actually controllers in our existing service. Then this path variable is resolved through this static function, and based on what you put it here, you either executed the user address service or subscriber address service. So it was implemented because it promises to make life of front-end developer a bit easier. Basically, you just send whatever user identifiable information you have for now into this endpoint, and you guarantee to retrieve something. But it was life of any backend developer a very difficult. Previously it was mentioned whose responsibility was it to manage security in the project. So backend's developer responsibility was to manage monitoring of the APIs. And with these input parameters in mind, any monitoring was very challenging. So let's actually explore another interesting decision. So each controller method is inheriting this abstract default controller class where all validation of the input parameters is handled. First and foremost, all validations can be done already at the input level during controller definition. You do not need to create some separate function to validate input parameters in Spring Boot. All of this code is completely redundant, not needed, but for some reason it's still introduced, it's still adds to the cognitive load of any developer who trying to understand what is happening here. So yeah, there the value is UUID or subscriber ID is defined by regex basically, and in process additional model class is created. So user data class. User data class is a static protected class which defined again in this abstract class, and it can use again only in controllers because it is protected. And it has also hard-coded getters and setters, even though the project have a long block. Again, completely redundant, not needed model, which is adapt some memory and capacity during any API execution. In addition, we have this interesting functionality validation. The request body is checked whether it is null or not. In Spring Boot, by default, request body cannot be null. Again, completely redundant validation functionality. But here I want to actually show you something else. So this is the controller which is responsible for updating address. So this is again the definitive controller which is responsible for updating only definitive address. But how does the backend service understand which address you want to update, taking into account that all addresses appear like delivery, interim, we're using the same request body and response body? Well, of course, you are breaking the object immutability rule in object-oriented programming, and you change the input value to the setter and add the type of the address directly into the request body. Why this value cannot be an input variable for the function? I don't know. The person who had implemented all of this had already left the project. Okay, so now I ask GitHub Copilot what it thinks about all of this controller class and its implementation. In result, I should receive the response, which consists of strengths and areas of improvement. So GitHub Copilot already wants to be a bit polite with me. It identifies that there's clear separation of concerns. The controller delegates business logic to service classes. So basically the bare minimum for each REST API is completed. Input validation is present. So maybe it's better to have any validation than none. Use of pulse variables and request body is standard for REST APIs. Again, the bare minimum is completed. Multiple routes mapping for backend compatibility or versioning. So it is the very interesting way to find any sort of advantage of using multiple path definition, which with this last statement I personally disagree. But let's revision areas of improvement. So can you actually see this text? If not, maybe I can again make it a bit bigger. So yeah, let's revision the area of improvements together. Again, method naming. So all methods basically using some basic naming like add address and update address. And GitHub Copilot suggests to use more specific get definitive address. With this one I agree. Next, HTTP status codes and error handling. This is the very good finding. I didn't notice it myself at first. I was completely taken away by all other wonderful implementation and architectural solution of this service. So yeah, definitely I do not know. Is this controller method returned like 400? Is this controller method returned 404 or 500? I don't know. Next, request validation. So GitHub Copilot suggests to use simple valid for address requests to remove any additional null checks. Constructor injection. With this I also not really agree. It suggests to make constructor public. I want to remove it completely and only use Lombok annotations. Road clarity and separation of user and subscriber logic. So this is definitely what I need to do in scope of my development ticket. I need to definitely make more clear roads and also definitely separate user and subscriber logic. This is actually one of my tasks that I need to complete. So next I will copy the first controller method in this controller class and ask GitHub Copilot to generate me the solution based on previously defined areas of improvement. So GitHub Copilot can maintain again conversational context as any GenAI powered chat. And with generated code I see that it is already much clearer than the existing one. It actually integrates the subscriber ID validation regex. I didn't actually reference any requirements to validate the input parameter. GitHub Copilot decided to do it for me, which is really great. It's a bit reduced the future refactoring. And next, I will ask it to basically generate the same controller method, but this time for users. So previous controller method was generate for subscriber. Again, GitHub Copilot can understand everything because it also uses the context of the previous conversation and it uses the context of the reference file and basically for all code base. So with this developer agent, I can easily integrate anything per textual request, which I will do right now. I will create another user address controller class and basically just add whatever GitHub Copilot has generated for me. I have utilized this again required our constructor Lombok annotation, and all of this make this controller class very small, even without the implemented create address and update address. I already see some improvements. Now I want to introduce how you can initiate legacy code refactoring through test-driven approach. Test-driven approach is when you create test first and then based on this test continue with either changing the logic or implementing the new one. So let me introduce you to the backend service layer of address changing. Yeah, unfortunately you will not be able to see it, but I really want you to see it. Let me maybe, yeah, let me a bit inhale the screen. So we have two get methods for address. We have two functions, one for user, one for subscriber. I already see that we have actually unused product ID input variable in this functionality. Again, a legacy artifact from the past. But I also want you to showcase how two different models, user and subscriber, are handled in scope of address managing logic. We again creating another internal model class called customer model. And by these model fields, subscriber, the UUID, first and last name, email and address data, you can see that both user and subscriber are basically one entity retrieved by different data. And this definition of the class is actually also not great. It's just public accessors instead of using more appropriate private accessors. Again, no getters and setters in place. And this implementation again uses a lot of additional memory and capacity of the program, which is not great. So let's now go down a bit. So I want to showcase you this address creation function. It is very big. It's so big that it's barely fit the screen. I'm very sorry you will not be able to see it, but I really want you to investigate this with me, so let's do it. First of all, we are validating product ID. Product ID is an input parameter directly from controller, and we are validating it in the backend service. So basically, we are retrieving user or subscriber. We are validating user or subscriber. We are converting this user or subscriber into the separate model, and only after that we are validating the input parameter from controller, the product ID. So many memory wasted. If I, for example, decided to input a valid product ID, it will be validated only here. Next, we finally can see where address type is used. So it is used to interact some validations. And this actually shows me that this function should effectively be three separate functions for three separate addresses. This if statement is valid for me because I am again operating with definitive address, but next if statement, this one, is not valid for me because I am operating again with definitive address, and this if statement will never be triggered in my case. Next, what I want to show you, this wonderful implementation of handling invalid address. So we are retrieving address from a third-party database, which then validates whether this address is something that exists or not. And how does it validate? It set the city code value from this address entity, and if the city code is greater than 0, then the address is valid and we can proceed. And if the city code is equals to -1, then address is invalid. This is not the problem of this monolith. This is specifically the problem of the backend database. But it is never documented anywhere in this service. Again, as a new joiner, I'm very confused with this logic execution. And actually, if we now go to this address entity field, you can see that this city code was actually introduced by completely other developer. Why? Because all these fields have public access, or this field for some reason have a private one. Again, no consistency, no coding standard in legacy applications. So this was the create address. And now I want to show you another implementation to actually update address. So update address functionality basically completely duplicating the address creation. it has same if statement, it has same logic retrieval components, as you can see, and after all of these if statements are executed, the update address function, again, calling create address, which is executing the same functionality again. So instead of using the creation address functionality from the client level, we are for some reason interacting with the functionality that completely duplicated the functionality that we have checked during address update. My IntelliJ actually already spotted the duplication here. This is why I'm using exactly IntelliJ because it can sometimes provide insights regarding the quality of your legacy code. So I'm a bit confused for now. So first things that I'm usually doing in such situations, I'm checking tests. This functionality has unit test. And oh boy, this unit test was first of all written long before unit tests have introduced parameterized test. Why? Because it basically collects all possible unsuccessful error messages into the list and then call a single function in this test class. And based on the input of this error message, it basically triggers different if-else statements and check different conditions of the code. So this test is effectively useless. This test is actually one piece of business logic itself. I do not understand what condition calls what. This all if statement should be a separate test. And if you are using if or else statements into your unit test, please stop doing it. It's very convoluted. It makes any verification of test logic much harder. So yeah, I asked GitHub Copilot to refactor this test. I asked it, please decouple this test into different test cases so I can at least read what they all meant for. So I quickly done it with chat, and now I can easily paste it into my code base. For some reason, the record is a bit slow, so I'm not doing it. Let's hope that, okay, I will just go there. So yeah, I'm just copy the functionality and paste it here. And after I have pasted the test functionality, which I have validated, I have checked that all tests are executed as expected, I can proceed with refactoring legacy code. So first and foremost, I'm referencing all related functionality into the GitHub Copilot chat to give it a context what I need to change. And then I again selecting this big create address function and ask GitHub Copilot to refactor it. But actually I have created a very bad prompt. I have asked GitHub Copilot to refactor address service, but I have not mentioned what specifically it should focus on during refactoring. So it outputted me this very, very long piece of code, which is actually very hard to validate and very hard to understand what was even refactored. This is because I didn't utilize the proper prompt engineering skills. So I will fix it quickly. I basically select, sorry, I'm showcasing the wrong thing. So yeah, I basically selecting the required function, the function regarding the address creation. I will copy the single function and put it whole into the GitHub Copilot. And I will ask GitHub Copilot to first of all decouple different components of its function so I can at least understand what is happening inside. And it's done its task pretty well. Now I at least can read out what each functionality is doing based on function name and can again proceed with refactoring. I will ask then GitHub Copilot to remove from this function any functionality that is not related to definitive address. Definitive address is by case, so I do not need all these if statements that are not related to it. And again, I will receive a pretty convenient response And yeah, GitHub Copilot also allows to support the changes it made in the code base, fix the documentation. And this is how I can spot who from my team is actually using GitHub Copilot to create code, because they forget to erase this documentation afterward. I will not forget to do it. And yeah, this is basically how you can improve the maintainability of your functionality. I will then make small adjustment in the process because I forget again to specify some additional refactoring requirements from the chat, but it's okay. I'm a developer myself. I can do something also on my own. I can also continue with maintainability part. I still have this strange part of functionality, and this time I want to document it for the future generation of developers so they at least understand what is happening here. So I will ask GitHub Copilot to validate this strange address validation functionality. GitHub Copilot is actually great in translating the hard and maybe sometimes convoluted code base into the humanly understandable language, which is very efficiently can fulfill the knowledge gaps, especially for the code that you did not create it yourself. Yeah, I have received the result with documentation. I hope you can see something here. And now I can continue with refactoring another function, this strange update address function, which actually had a to-do comment asking for future refactoring, which I will fulfill now. I will ask GitHub Copilot to refactor this big update function. This time I will also ask it to reuse already implemented functionality, which I have done in the previous iteration of refactoring. And with that, I will also ask GitHub Copilot to fix, to check that all tests are executed as expected. And with that, basically it. This is how I initially used GitHub Copilot with this legacy code base, and it helps me a lot to improve the I would say consistency of my code. First of all, from monolithic, tightly coupled, and how to modernize architecture, it's create a more modular, more loosely coupled, and definitely more scalable code base. Next, it helps fix to inconsistent coding standard, and now the code base in our monolith at least following some industry-specific standard. Then it helped increase the test coverage for our very poorly covered monoliths up to 75% in average. It has also helped us to create the documentation, and it overall makes the integration of new component into this monolith much more easier. So now, let's discuss why you might want GitHub Copilot in your project. First of all, you are already using GitHub as your source code management platform. So GitHub Copilot provides a lot of functionality within GitHub, and it will be a bit wasteful to use Copilot if you, for example, hosting your code on GitLab. Alternatively, you can use other AI code suggestion tools. GitLab provides GitLab Duo, for example, and if you want to be more platform independent, you can use other AI code suggestions tools like AWS provided Amazon Q Developer or GenAI Code Assistant from Google. Next, you have varying capacity in the project. What does it mean? 1 week, you have no tickets to complete. Second week, you have like 3 or 4 spike tickets with time box of 2 hours each, which you need to implement very fast. GitHub Copilot can provide timely assistance when it is required the most, and it can also be utilized in learning new languages and frameworks when you have less capacity sufficient tasks. Next, you want to bring innovation into the project. So using AI tools is very beneficial for any project, especially nowadays, because believe me, your competitors already using it. So First of all, GitHub Copilot can introduce a lot of advantages. It can accelerate code creation, code refactoring, code testing, code documentation, everything related to managing business logic. In addition, it can reduce some loads from senior developers by automating code reviews, for example, and it can also help new joiner by making the onboarding process easier for them. And next, you have a tech debt in your project. I have already shown you how you can minimize it through GitHub Copilot refactoring effort. So if you want to modernize your code base without spending much time and resources on it, you can consider GitHub Copilot as something you can introduce into your project. Next, how you can introduce GitHub Copilot into your project. So, first of all, you need to establish a clear guidelines for GenAI tools. It is important to mention that if you're introducing some GenAI tools into your project, it doesn't mean that project members now can upload your code base to ChatGPT or Cloudis only because they're using same large language models. It is important to make some boundaries. We can use only GenAI tools that are currently approved by the project. So GitHub Copilot is approved, you can use only this tool and nothing else. It is actually a very good approach to introduce GenAI guidelines also for the projects that are not using GenAI. Basically, again, make boundaries that not any, and basically GenAI tools cannot be used with your project base without approvals. Next. You can start piloting GitHub Copilot in the small groups. So before making some long time commitment, for example, buying the subscription for a whole year, you can first, for example, select 4 or 5 developers from your team, or 1 developer if you have a small team, and pilot GitHub Copilot, for example, for a month. And then continuously gather feedback from this piloting group. What does GitHub Copilot can complete better? What does GitHub Copilot can complete worse? In what environments is it the most efficient? In what environments it is less efficient? All of this feedback help you understand if GitHub Copilot is something that you really need, that you want to implement. And if you decided to implement it, you need to make GitHub Copilot part of your onboarding process. You need to make sure that all developers in your team know that you provide access to GitHub Copilot, that developers can acquire this access, that new joiners can know where they can request this access. Maybe you want to introduce some additional trainings before you provide full access to GitHub Copilot. All of this must be transparent for all of your project members. It is important to notice that GitHub Copilot will not magically solve all your issues in your project. So I have a very mixed reviews and feedbacks from my project members who are also using GitHub Copilot. Some of them are very happy with it. They think that GitHub Copilot is their best pal and best friend during development. Others think that this tool is completely useless. It cannot provide me any official suggestions. I disable it in my development process. This is because the less maintainable code you have, the worse responses and suggestions GitHub Copilot may provide for code suggestions. You might notice that during my demo I haven't used code suggestions, I have used chat, because chat has surprisingly consistent efficiency, depending on your prompt engineering skills, of course. So the more legacy code you have, the more you should rely on the chat. And when you will be able to make your code base better through chat assistants, you will notice that the efficiency of code suggestion tools have risen exponentially, basically. And yeah, GitHub Copilot is not the solution for vibe coding. If you are not familiar with some language, with some framework, please do not use GitHub Copilot to write your code for you. as a developer, you are always responsible for the end result, whether it is written by you or AI generated. When I have requested changes from GitHub Copilot, I understand the Java language rules. I understand what end result I am expecting from it and how I can verify that it's working as intended. So if you, for example, learning new languages, it is better to grasp some bases first and only then start using GitHub Copilot for assistance. So yeah, this is basically all from my side. GitHub Copilot is the best. Please implement it yesterday. This is me. You can go to my LinkedIn, and if you have some questions, I'm happy to answer them now.